Hi everybody. Okay, so we're on to subsection 5, functions. Part 1, domain and range. Okay, so this is a concept we've been using for, again, a very long time, but you first learned it in grade 10. Okay, so anyways, there's two notations, remember. There's set builder and interval notation, and well, interval notation is pretty much what's used for Math 31. It's not a bad thing to know both, so we're just going to do both for these, and then we just kind of cover our bases. So anyways, example 1, what is the domain and range of the following function? Now, sorry guys, oops, this was supposed to be a little lower so that it actually went through that point. So we're just going to pretend that it went through that point, so yay. Alright, so if you have a look at this, please notice the arrows, so that means that this goes on forever. Okay, so that's awesome. So this is the basic parabola. So the domain for this, okay, is x such that x is an element of the reals. Yay. Okay, so we have these swirly brackets and the x such that. Okay, so that's how we do that. This is set builder. Set builder. Okay, awesome. Okay, so the range for this is y such that y is bigger than or equal to, okay, let's see, negative 1, negative 2, negative 3, negative 4, negative 5. So we are bigger than or equal to negative 5. Okay, so shortcuts for this, like this is the official way of doing it with the swirly brackets and the x such that. A lot of times you'll just see people kind of shortcut this to x is an element of the reals, and then the range y is bigger than or equal to negative 5. Okay, so this is official. This is, well, I don't want to use the word lazy, but just kind of shorthand for that. Okay, so that's that. Let's do the same thing for interval notation. So remember, interval notation just talks about the start and the stop. So for the domain, how that works is, okay, well, remember, it's everything. Okay, x goes on forever. There's no value too big or no value too small. So it goes from negative infinity to positive infinity. Okay, and you're never allowed to equal negative infinity. So that's why you have a circle bracket or a curved bracket, and you can't equal positive infinity either. Okay, the range, on the other hand, okay, the low end is negative 5. The high end is positive infinity. Okay, you can equal negative 5, so you have a square bracket, and you can't equal infinity, so that's the circle bracket again. So we have set builder, and this one is interval. Again, you've been using these for a while. Okay, so guys, for what we're going to do, the official versus the short version, I'll accept either. Okay, I'm not too worried about that, but you need to at least see the official part, so all good. All right, so let's look at example number 2. Okay, what is the domain and range of this one? Okay, so this is kind of a piecewise function, so we haven't seen a lot of these in any of our previous courses. It's really not a big deal, it's just kind of they step up like this. Remember, an open circle can equal or is greater than or less than, but never equal to. A closed circle is greater than or equal to. All right, so if we look at the domain for here, and let's just do the short version. Okay, so the domain starts at negative 8 and goes all the way up to 1, 2, 3, 4. So negative 8 to 4. So negative 8, domain is always the next thing, and 4. Okay, well, we are allowed to equal negative 8, so that's equal to. Okay, greater than or bigger than or equal to. Okay, and then the 4 we have to be less than, but it's an open circle, so we're not actually allowed to be 4. Okay, so there we go. If we look in the middle, there's this weird break at -2, so we can't equal -2 on this line, but we can equal -2 on that line. So that this is, we would call at least the domain part of this continuous. All right, so that's that. The range for this, range is weird because there's really only two values that the y can be. The y can be negative 5 or negative 3. That's all it can be. So we just say negative 5 comma, -3. That's it. Okay, so that's that one. Okay, so that's good. In interval notation, we would say we can equal -8, okay, but can't equal +4. Now the range for this one in interval notation, we don't typically do interval notation for stuff like this where it's not continuous, it just jumps. Okay, but if we were to force it into being, we would say, all right, well, you can equal, okay, you can equal -5, okay, or you can equal -3. Okay, all right, so that's that one. Moving on to example 3. Okay, the domain and range of this one. Hey, this one's pretty straightforward because look, it's a line and it goes on forever, so oh yay. The domain, x is an element of the reals, the range, y is an element of the reals. Awesome. Okay, in interval notation, okay, so that is -infinity to +infinity, and the same for the range. This is by far the most likely that we have. Okay, so that's that one. Okay, and then number 4. See, this is a little weird squiggle that stops. Okay, usually these go on forever, but because they have the dots there, okay, they stop. And this is just more for the domain and range part. Okay, so the domain for here, we start at, so that's -8 and goes up to +9, and we have everything included in between. So -8 to x to +9. Oh, I'm sorry. We have an open circle around the -8, so that is why it's not equal to just, okay, x is bigger than -8, but smaller than or equal to +9. Okay, for the range is interesting because the range, the top part of the range is there, and the bottom part of the range is here. So this is -9, and this one is +7. So when I do range, I like to go from the small one to the big one. So y is in between -9 and +7. Okay, and I can equal -9 and I can equal +7. So really this open circle does not affect the range at all. Okay, so this is a course builder. So in interval notation, okay, we have an open circle or curve bracket, -8 to 9, square bracket, and the range for this, okay, so -9 up to +7. Okay, and that is it for part 1, guys. Thanks.